Hello, students. We are going to do some work today on making up anything that you might have missed or anything that you need to review for September 28th, Sesame Street Genetics Day 1. We're going to start out by making sure that you have your notebook set up, and this is just a quick check to make sure that things are done. So your notebook should have your first page here as genetics. You can subtitle that as Sesame Street Genetics. This is a new unit. Sometimes I like to put a little marker in so that I can see I've started a new unit. That's not required, but you might want to do that. The second thing is that on the back of this page, you're going to want to put in your glossary. You're going to have three different columns here. You'll have a term column, a definition column, and a prove you know it column. You can see that as I was writing this in, I didn't leave quite enough space. So when I'm doing the prove I know it, I'll need to use this space for sexual reproduction, this space for meiosis, and then gametes. I left out enough open space here so that I can put that prove I know it in. The prove you know it is a place for you when you are studying to make sure that you can show or say in your own words or diagram the basic concept of what that term means. So it's something there that is helpful to you. There are 5 terms that should be in your notebook at this point in time, or actually today, there will be 3 terms in your notebook today: sexual reproduction, phenotype, and genotype. And we'll get to those in just a couple of minutes. For your table of contents, label at the top table of contents, put in the date. For 928, you don't actually have anything to put into your table of contents, so you can just set this up: date, topic, page, and learning targets. For Tuesday, you will have something to put in. You can put that in now if you want, but you don't have to. Okay. We're going to work through something called Sesame Street Genetics this week, and our entire assignment will be due on Friday. We're pretty sure that we'll get through it in that amount of time, and I'm going to take you through the basic work that we're going to do in this slides presentation, and you can access the slides presentation. It is right here, 2021 Genetics Unit, Day 1. That's what we're looking at. So we're going to do Sesame Street Genetics. And we're going to spend some time learning about how genetics works using these Muppets. Their species name is Sesamus muppetus. The first thing that we'll do, though, before we get into learning about this, is go ahead and put a few words into our glossary. So you will need to you can use this presentation if you want to pause, but you're going to put in sexual reproduction, and you're also going to put in phenotype and genotype. You can access those in the slides presentation that you have access to in Google Classroom. What we're going to go ahead and do now is start to work through the genetics of Sesame Street characters. So here's kind of the basic idea about the genetics of Sesame Street characters. And again, you have this document in Google Classroom, and you're going to do some work in this document yourselves. So for the genetics of Sesame Street characters, as we said, Sesamus muppetus, that is the genus and the species here. So we have some information about them. We've had scientists that have been studying about these characters for quite some time. And this process of karyotyping, which is looking at the individual chromosomes and figuring out what genes are on those chromosomes, that's karyotyping. Karyotyping reveals that Sesame Street characters have 6 chromosomes. Sesame Street characters have 2 chromosome 1s, 2 chromosome 2s, and 2 sex chromosomes. They either have 2 X chromosomes or an X chromosome and a Y chromosome. And just like in a related species, Homo sapiens, that's us, if there are 2 X chromosomes, that codes for female, and if there is an X chromosome and a Y chromosome, that codes for male. Through the process of gene mapping, so in looking at all the information that is on each of these chromosomes, scientists have found that eye shape is on chromosome 1, nose color is on chromosome 2, body color is on chromosome 2, and lip color is on chromosome 2. Scientists have also found that hair type is only on the X chromosome. The Y chromosome doesn't have any part up here like the X chromosome does, and there is no gene for hair type on the Y chromosome. I think I just said something incorrectly. Eye shape is on chromosome 1 and nose color is on chromosome 1. We're going to go through part of this today. We're going to go through the first 3 sections or first 3 parts of the procedure. So we're going to describe the traits on the table on the next page, and then we're going to use those traits to determine the genotype or the possible genotypes of each Sesame Street character for each trait based on each character's phenotypes. And then we're going to put those on the table. And then you're going to answer some questions on your own. So let's go ahead and start with this. This is the first thing that we will look at together. So we're going to look at the characteristics. When we look at this, we're looking at the phenotype, and you just put this word in your glossary. The phenotype looks at the physical characteristics. For our purposes, phenotype gives us the physical characteristics, and you can hear that those sound very similar, and that's how you can connect them in your mind. The genotype looks at the genetic information. The genotype looks at the genetic information. And so that GEN here in genotype and the GEN in genetic information, that's how you can connect those as well. We're going to talk about a few different types of inheritance. We're going to talk about something that's called dominant and recessive, and this is pretty simple. We're going to talk about incomplete dominance, which is a little bit more complex, but not much. And then we're going to talk about dominant and recessive that are sex linked. So when we're looking at eye shape, if we take a look at some of our characters here, let's look at Abby to start with. And if we're looking at eye shape, we're going to see whether that character has flat eyes or, like Elmo over here, has rounded eyes. So the phenotype is exo, which those are the eyes like Elmo's, or endo, which are the eyes like Abby. For each phenotype, there's at least one genotype. So there has to be some genetic information that codes for the structure to be formed. So in this case, if the genes that we find here on, let's say, in Abby's chromosomes, so if we have one here and one here, that's what we have. We have an eye-shaped gene here and an eye-shaped gene here on chromosome 1. If we go down here and look, Abby has the flat eyes, so she would have what's called the recessive form of the gene for eye shape on one chromosome, and she would also have the recessive form of the gene for eye shape on the other chromosome. If we look at Elmo, on the other hand, his eyes pop out. So he could have one of 2 genotypes. And you can, when we do this later on, you can choose. He would either have 2 dominant forms signified by the capital letter here. So a dominant form, which would cause the eyes to pop out, and another dominant form, or he could have a dominant form and a recessive form. This we call homozygous dominant. This one we call heterozygous. If we look at Abby's genotype, which would be this, we call this homozygous recessive. We're going to learn those words as we go through, but it's not absolutely necessary that you know them right now. When we look through this chart, we can see what different phenotypes or different physical characteristics we can see for each of these traits or characteristics. And that would be eye shape and nose color, lip color, body color, and hair type. The simplest way to figure out how this chart works is actually just to dive in and do some of this work. So we're going to look at this chart, and I'm going to split it out so we can see it like this. There we go. And we're going to look at our PowerPoint over here, or what's actually our slides presentation. And there we go. I'm going to take this back to normal size. And we'll fill in the information for Abby as we go. So when we are looking at Abby, here's Abby right here. This is Abby. When we look at Abby, we see that she has flat eyes. So we're going to type in right here that she has flat eyes. Or I'm going to type it in here. You're going to type it in on your Google Doc. And we can see that with the flat eyes, her genotype would be little e, or homozygous recessive. Homozygous means the same, and then recessive means the one that, like the dominant, if it is present at all, it will show up. For the recessive, you have to have both of the genes, both of the forms of the gene to be recessive in order for it to show up. Okay, we're going to now look at Abby's nose color. So Abby's nose color is pink. So I'm going to write in here, pink. She can either be homozygous dominant or she can be heterozygous. So in other words, she can have a dominant allele or dominant form of the gene on each chromosome, or she can have a dominant form of the gene and a recessive form of the gene on those two chromosome ones that she has. So we're going to go with heterozygous. For lip color, on some of these guys, it's a little bit hard to tell. If they don't have lips, Grover has lips that are pretty clear, but otherwise, just try to see what you think the inside of their mouth looks like and pretend that you've got some lips there. When we're looking at lip color, we have the options of magenta, red, or purple. So I'm going to go with magenta for Abby's lip color. And then for body color, Abby is pink. So I'm going to look up here. When I look at, let's see, we're going to go with magenta for that as well. And so that is a capital B, capital O. Now, this is called incomplete dominance, which means that both of the alleles will produce a color. And so if you have both of them, you'll get some kind of a mix. So if you had BB, or if you were homozygous for the B alleles, you would be blue. If you were OO or homozygous for the O alleles here, you would be orange. She is heterozygous BO, and so that makes her magenta. Okay, so body color here, magenta, B and O. This is not supposed to be hair color. This is actually supposed to be hair type. Let me fix that.
Please pardon the interruption for a couple of afternoon announcements to end our day. Teachers, students, another really.
Okay, we got a little bit of the afternoon announcements there. Coming back into our presentation, we're going to look at hair type. And when we look at Abby's hair type, she has hair. Grover does not have hair. Elmo does not have hair. We can look at those later on. But Abby does have hair. So we're going to say for hair type, she is hairy. So we're going to write that in here. And this is a little bit different setting. This is a little bit different situation. This is a sex-linked trait. We know that Abby is a girl, so she's going to be capital X, capital X. That shows that she has two X chromosomes. And in order for her to be hairy, she can either be capital H, or capital H, little h, which means homozygous dominant or heterozygous. For this one, we'll do heterozygous as well. So the way that I'm going to have you write this is you'll put in the X and the dominant allele here, the capital H, and then the other X and the recessive allele here, the lowercase h. So this is how you would go through this information for Abby on your own. What I would like you to do now is to pause and to go through Grover on your own. Okay, so now that you have taken a couple of minutes to do this work on your own, I would like for you to check your answers. So you should have typed in the box over here in your document. You should have typed in the information that we went through with Abby, and now you should have typed in your own information for Grover. You can check that over here in the PowerPoint that I've just shown you. Um, Grover has flat eyes, so his genotype has to be homozygous recessive. He has a pink nose, and we'll go with homozygous dominant since that's different than Abby, just for showing you that either of these could work. His lips are red, so that's a heterozygous genotype, one dominant allele and one recessive. And then his body color is blue, so he is homozygous for the B allele. And Grover is bald. Well, this is a little bit different case than we had here with Abby because Grover has an X chromosome and a Y chromosome. If you remember from looking at the chromosome map here, the gene map, the Y chromosome does not have any kind of a gene for hair type. Only the X chromosome has a gene for hair type. So there's nothing on this Y chromosome for whether Grover is bald or has hair. He only has that gene, so he only has a form of that gene on the X chromosome that he has. Since he's bald, and we know that bald goes with the lowercase or recessive allele, we know then that Grover has to have one of the recessive alleles on his X chromosome. What you need to do for the next part of your work is to go through Elmo, Zoe, Telly, and Honker and fill that information in on your document. So you're going to go through Elmo, Zoe, Telly, and Honker and fill that information in as you go. You'll need to go through the genetics of Sesame Street here in these questions here in the genetics of Sesame Street. So go ahead and answer all of these questions on this page. There are 3 questions with a few parts. Most of these are really, really short answers, and that's all that you have to work through. But use this video and use the work that you've done with your figure number 2, and also use the information that's in the top part of this form.